Hey guys, welcome back. Today we're going to talk more about the square root property, and we're also going to add in the zero product property and kind of combine them together. We're just going to solve some more equations. But the first one that I want to talk about is just this equation here, x plus 6 squared equals 12. And everything we've done so far have had pretty nice answers where we can use either the zero product property or we can use the square root property. All of our answers have been either integers or they've been fractions, and we're going to come up to some answers that have irrational numbers or square roots involved in them. And here's an example of one. Notice the left side is a perfect square, but the right side is not. I'm still going to use the square root property here, and we'll see what the answer looks like. So the square root property would say we can take the square root of both sides equals plus or minus 12, square root of 12. And then you get x plus 6 equals plus or minus, well, the square root of 12, that's not a perfect square, so we're just going to leave it as radical 12. So x plus 6 equals plus or minus our radical 12 here. And then we have a couple of possibilities. You have the possibility that x plus 6 equals the positive version of this, so positive square root of 12, in which case x would equal, and we're going to leave it right in this form, negative 6 plus the square root of 12. And that'll be our final answer. And we also have the possibility that x plus 6 equals the negative version, equals negative square root of 12, in which case x would be negative 6 minus the square root of 12. This would be another solution. Making our solution set negative 6 minus the square root of 12 and negative 6 plus the square root of 12. Answers look a little messy, but if we don't have a perfect square, we just want to leave it as the square root. We don't want to round it to a decimal or anything. We want to keep its full value there. So this would be our final answer in radical form. And again, the answers might not always be nice, but the square root property will give you the exact value of that. And we'll see more of these in the future, especially when we get to solving quadratics. But I just want us to recognize this form and not be intimidated by it at all. Still taking the square root of both sides. The only difference here is it's not a perfect square, so we're going to leave it in that form. Like if this was the square root of 16, we could write 4 and then we can combine terms. But right now we can't, and we're not going to try to turn it into decimals. We'll just leave it as a nice radical here. So let's move on to some other ones, now incorporating the square root property or potentially some other properties that we've seen in the past. Our next question that we want to solve is what's the value of y in this equation that makes the equation work. So we have 2y squared equals 32y. So if you're trying to use the square root property, you should look, are they perfect squares? Unfortunately, they are not perfect squares here. There's no square root to 2y squared, no square root to 32y. So if it's not a perfect square, there's a couple things you can do. One of the options you should think of, can we use the zero product property? Meaning, can we get everything to one side, subtract your 32y, set it equal to 0, bring in the 32y over, and then can you factor? So can we factor here? Well, they both have a 2 in common. They also both have a y in common. So we end up with 2y times y minus 16 equals 0. And then we can go ahead and we can solve this. So you have one polynomial, it's a monomial, 2y times this binomial. So if you multiply two polynomials together and they equal 0, one of them or both of them have to equal 0. So 2y equals 0 is one possibility. So we have the possibility that y equals 0. And let's say this one isn't 0, but the binomial is. So the possibility that y minus 16 equals 0, so therefore y would be 16. And your solution set would be the set containing 0 and 16. There's your possible solutions here. So this one, I think the better method to go with would be to use the zero product property. Get everything to one side, have 0 on the other, and try to factor out. As you do more equations, solve more equations, you're going to start to recognize when it's better to use which method. So our next one, we have 4x squared plus 121 equals 44x. Now right now, notice the right side isn't a perfect square, the left side isn't a perfect square, It's close to being a difference of squares, but we're adding, so it's not going to work for us. So I would try to get everything to the same side here. 4x squared, I'm going to subtract 44x, and I'll list things in order of degree. So minus 44x plus 121. We subtracted the 44x, so we have 0 over here. So we should be thinking, can we set up, or can we factor this so that we can use the zero product property? Well, if we look, the 4x squared is a perfect square. The 121 is a perfect square. If you take 2 times the square root of 4x times the square root of 121, you'll end up with 44x, which we have here. So we have a perfect square, and we're going to have 2x minus our 11 squared equals 0. And you can use the square root property if you want. You can use the zero product property. You can kind of think about it logically. If you have 2x minus 11 squared is 0, well, what squared equals 0? 0 squared is 0, so 2x minus 11 has to equal 0. Then you add your 11 to both sides, divide by 2, so x is 11 halves. So x is 11 halves, and we only have one solution for this. You don't have to have 2 solutions. You could have a maximum of 2 solutions because we're degree 2. But we have one solution, and that's fine. All right, our last question of the day. And let's see, we have x squared minus 10x plus 15 equals 26. So the left side, let's see, left side's not a perfect square and the right side's not a perfect square. So square root property might not be the best way to go, but let's go ahead and get everything to the same side then. You can subtract 26 to bring it over here, and when you subtract 26, you're going to end up with minus 11, and have equals 0 over here. And now we can use factoring like we have in the past to set up the zero product property. I know it's not a perfect square because that minus 11 is not a perfect square, so we're going to have 2 binomials hopefully, if we can factor. So let's go ahead and try to factor. Well, we're looking for a product of negative 11, so that negative sign means we would have a plus and a minus, and it needs to add up to negative 10. So factors of negative 11, well, 11 times 1 is going to equal 11, so one of those needs to be negative, and if we make it a negative 11 and a positive 1, when we end up adding, we'll end up with that negative 10. So this would be the factored form, and now we have 2 binomials multiplied together to equal 0, so we have 2 cases, either x plus 1 equals 0, and x equals negative 1, or we have x minus 11 is 0, in which case x would equal 11, making our solution set negative 1 and 11. So here we go, we have square root property, also the zero product property. We're going to try to see if we can decide when to use each property when solving an equation. Alright guys, that's all for today. Have a good day.